Welcome everyone to this new episode of Modern Aerospace. I have the pleasure to have Guy de Carufel today with me. Guy is the CEO and founder of Cognitive Space. Welcome, Guy, to this podcast.
Excellent. Thank you for having me.
Yeah, so Guy, I'm very excited to talk again about the new space, about like your company. Very excited to being able to dive a little bit more about like what your company is about, like your background. So I want to start with let's start with your background in the industry. I want to understand like what's your background? How did you ended up to basically create your company?
Yeah. So I can go back to what got me interested in space in the first place. Back in college, I was in mechanical engineering, and I found a passion for space mainly through, I'd say, the happenstance. So, landed in there was a webinar, well, at the time not a webinar, but a forum where someone talked about the future of space and where that's going. And at that point, my understanding of space was that it was a very closed environment, limited to governments and large corporations. But it sounded like the space market was opening to smaller industries, and it was actually possible to get into that market. The joke at the time was to be a millionaire in space, you have to be a billionaire to start with, right? And that's certainly true for the likes of Elon Musk and things. But there's definitely opportunities now where the market is flourishing. It's really starting to grow quickly. So going back, got interested in that. Went to University of Toronto, and that really opened up my aperture in terms of understanding that you could do a lot with a small satellite. Even that at that size, you can do real science. You can even do monitoring of ships with AIS. That's one aspect, and we actually built a fleet of satellites to do astronomy, which was super interesting. So that's really how I got started. I was helping build satellites there in Toronto. Then I moved down to Houston through common connections through the International Space University. That's another story. They call them Space Mafia, but I ended up in Houston, where I started working as a contractor for a company called Odyssey that supported NASA at JSC. So that really got my professional career going. Apologies.
Yeah, got your career going at that point in time. What was the activity of that company exactly? There was like
So
a
Odyssey
satellite
was a software
manufacturer.
company, and they would work with Johnson Space Center
Okay.
to develop software for spacecrafts, software for ground systems, how do you command spacecrafts, and working on programs like the International Space University, Space Station, ISS, and other programs like that. So I worked there for about 6 years, and then I ended up in Austin, where I worked for Firefly, a launch vehicle company. Unfortunately, that iteration of Firefly did not make it. So I came back to Houston and started working as a consultant, which eventually led me to start this company, Cognitive Space, 6 years ago. So long story short, I got interested in space, and then I also got interested in the space market and what that market was looking like. There is still a lot of friction in the industry, and there's new technologies now that are available that can really help reduce that friction and help the industry as a whole just thrive and reach its full potential.
And when you were working as a consultant, what type of mission of services were you provided? What type of expertise
I
were you
was
provided at
providing
that time?
expertise in terms of software development integration. I was working on the Orion program at the time, integrating a sophisticated optical sensor into the Orion spacecraft to do navigation, and then how do you
Capsule.
command that spacecraft from the ground. And so a lot of flight software, ground-based systems and things.
So what is the impact of that consulting work in the discovery, I would say, like of a specific problem that you later
Yeah,
try to solve with your current company? Was
Yeah,
that where you
it wasn't
found the different
exactly the
problem?
same problem, but what I learned from working at NASA on the Orion program was that first, NASA, who obviously is building exquisite satellites, is still using very, I'd say, tried and true, but sometimes deprecated approaches of how do you write software and how do you manage, how do you test software, etc.
Mm,
And that made me curious as far as how could you apply new technologies like AI to automate a lot of those approaches for, say, configuration of your spacecraft or commanding of the spacecraft. And so that was sort of the first seed of interest as far as what could be done better. And so I looked at the commercial side, and
mm,
I have some friends that work in the industry at different companies, and through discussions with them, I also learned that even the industry was still using fairly simplistic methods of managing satellites, and not leaning in on newer technologies like deep learning technologies and things like that to automate how you go about managing satellites effectively, to do things like remote sensing, collection planning, or link management, or just management of your systems as a whole. So that's really how the company got started, as far as the initial concept, and then um, I traveled a lot, built the first prototype. The first 2 year was essentially just me as the company, and built the first prototype. Through my experience in software development, and then went to conferences and met an interested party in the Air Force Research Lab, which ended up being our first contract. And then we did a lot of research contracts through that to really get started, to allowing me to build up the team and then build more of a product along the way. So, yeah, and then that also allows us to expand and then also, go back to commercial and look at how newer companies that are looking to deploy satellites, how can we help them manage their satellites more effectively?
So that's really like this research contract that help you. I mean, at the same time, like build the technology, but as well like build your team and get like ready for talking with outside investors and try to start to raise capital for this new company, right? That's really like what's helped you
Yeah,
to
so
grow.
starting a company, the first raise is very much of a bit of a chicken and egg situation where they want to see some kind of traction, but then to get traction, you have to have some capital
Mm,
to be able to really build something of value. Um, so the first 2 years, I participated in an accelerator program called Creative Destruction Labs. Opened my network quite a bit on the investment side, but also uh, taught me some basic fundamentals of running a business and starting a business. So through that program, I tried to raise money. Quickly realized that I was too early at that point. So after spending about 3 months trying to raise money from all sorts of investors that really I had no business in talking to, I went back to building a prototype, building a proof of concept to really showcase, prove it to myself that I could use machine learning in the problem I was trying to solve, and also build something interesting for potential customers. So that's really, I'd say, the first step in my journey was building a prototype that was more than just a PowerPoint, right? And then having that proof of concept to then be able to close first customer. And that was not an easy journey. I tried many times to get SBR contracts. Got rejected about 7 times before actually landing the first one. So, it definitely took some time to get there. But once we got our first contract in the door, that really got things moving, and I was able to bring in, hire the first engineers in the company, which were the best engineers I knew. I brought them on, and then we started building the team,
mm.
and then winning more and more contracts as we went. And then as far as the fun, yeah.
So
So
yeah,
yeah,
yeah, I'm curious about timing
yeah, and
between
then
those
as far as
different
the
steps. Yeah.
fundraise, after landing our first customers with the Air Force, that really got investors more interested at that point. And then we did the TechStars program this summer, which obviously
Mm.
is a great program, and really helped me expand my network again from an investment standpoint. And then I was able to close a pre-seed round in 2020. And then with that, we were able to grow our team and then expand what we were, our product roadmap, what we were trying to do. Um, we grew our presence with the government winning several other phase twos and direct to phase two and even a phase three. And so, the Air Force really helped us at that point and helped, like many other companies in space that got started through the AFWorks program at the Air Force here in the U.S. That really helped us going, and then grew. We grew our team, grew our revenue base, and then we were able to close another round, a seed round at that point in late 2021. And then and then we grew some more and expanded to commercial in California, and that was really our first anchor customer that from which we learned a whole lot in terms of what does it take for a product to actually be functional in a live environment. So really mature the program product from that. And then last year we raised another small seed extension to bring us to where we are today.
Well, that's amazing, honestly. Like, congratulations just for those different steps. It's a pretty good achievement. Knowing like how challenges it is to grow a company on the new space industry, I would say. Um, can you describe a little bit more like your services, like and the product itself? Like, what do you deliver as a value to your customers, and maybe showing the difference between like a government organization relationship and also like a relationship with private and
Yeah, so the,
commercial
the relationship
companies.
with the government and commercial is different in the sense that government wise, it's more on the demand side of an organization that's looking to acquire space data for their needs for national security. Um, on the commercial side, it's more on the supply side. So working with them to help them manage their satellites to output more data. All right, so they can be more successful as a company and be more responsive to the end customer, which oftentimes is the government, right? And so there's definitely some synergies there, and allow us to be very focused on that use case, from a national security standpoint. Um, what the value we're bringing to customers on the commercial side, it's really how do we help them automate their processes so they don't have to spend a lot of time trying managing their satellites and their customers through spreadsheets and trying to predict, looking at the weather and looking at a simulation engine to see like, okay, when is that satellite going to be available, et cetera. And so making that in a simple sense, it's a logistics problem that we're solving for them and making it a lot easier to schedule their system and automate a lot of those manual processes. And we are leveraging machine learning in doing that. In how do we in automating payload scheduling, which is when do they want to take imagery, when do they want to select one target or another, and then when do they want to downlink that data through which ground station. So there's definitely a lot of integrations involved. But what we strive to do is really reduce the friction for the operator so that they don't have to do they have to do significantly less work to get to their objective, which is meeting the requirements of their customers.
Can you share like a basic overview about like how I would say legacy satellite management system were working in the past? Um, Maybe listing as well like the type of parameters that they were integrating in their calculation, I would say, and what we can do today with applying machine learning AI on the management of those different satellites and the benefit that you can get from that. If you can just show the
Yeah,
difference between the
so
two type of approach?
traditionally, satellite operators have built those systems in-house, mainly because of a lack of alternative. But what they would do is start with what's called the command and control, or the TT&C, which stands for telemetry, tracking, and command, which is the low-level infrastructure that's needed to command the spacecraft, and just putting together some command packets so that they can tell what the spacecraft to do and when to download the data, etc. So starting from that point, they can then start to put together some rudimentary scripting to try to automate some of that, and then they can put on layers on top of that to be able to accept orders from customers, prioritize those orders, and then hopefully try to streamline that process as much as possible. So that's usually how these companies go about selling their data and managing their systems, which is in a very organic fashion, which definitely has worked for companies so far. So you can look at Planet, Maxar, Black Sky. So they have built systems in house, but it was a significant investment on their part of several years. In the case, 5+ years in the development of those, and several iterations of trial of building a system, scrapping those systems, rebuilding those systems, and so it's definitely a major investment for these companies to try to build a system that's scalable and that's streamlined, and then they can accept orders easily. Um, Even there, a lot of times these systems will be built very specifically for the early satellites that they're deploying and they're managing, and they are hard coded with some rules that makes it effective for those satellites, but not effective for the new generation of satellites or the new sensors that they're deploying. And so it makes for a brittle system that is hard to maintain, hard to scale. And so what we bring to the market is really kind of a new approach, and that is leveraging new techniques like machine learning, where instead of uh, instead of writing very specific algorithms that are tailored for a particular satellite, we capture the behavior of that satellite in a simulation environment, and then we train a neural network to understand that behavior and understand how that satellite should behave against an objective function, which could be many different things. Fundamentally for satellite operators, it's revenue. How do they optimize against revenue? But it could be other things, like how do they reduce latency in getting the data they need, responding quickly to the customer, or prioritizing a customer, or potentially the quality of the imagery that they're outputting, that they can optimize against that. So there's different metrics you can optimize, but with a neural network or a deep learning approach, you can quickly make changes to that objective function without having to rewrite everything. You simply make some adjustments and then retrain the system to then change the behavior the way you want it to. So that's really kind of the advancement that we're bringing to the market from an AI perspective, is that new approach of managing systems to automate how you're scheduling your assets, to account for all of the different permutations that you have to deal with, which are things like weather, like ground systems availability, like sun elevation, or particular requirements that a customer may have around time of the day, time of the year, and how do you marry all that, and while considering the business implications of the objective of the company to meet certain guarantees they've made to customers, or pricing commitments they've made, and things like that.
Do you have specific, I mean, I don't know, like data figures that show how the improvement of such technique and processes over like traditional legacy system? Like we're talking about like how many time improvement,
Yeah. So
in which
when we
parameter?
worked with Terran Orbital, one thing was clear, was that we were saving a ton of time in the scheduling process of taking an order from a customer and turning that to a schedule to send to the spacecraft. And we were reducing the amount of time required for that process by about 90%, based on the metrics that they've reported. And so that just from that perspective, obviously that brings a lot of value just from a streamlining processes, but also in being more responsive to the customer, in being able to respond quicker to an order, but also be able to accept more orders, given that they have more bandwidth to be able to process those. The other one, metric is just comparing our system with some common algorithms are used in the industry when it comes to automating for collection planning, primarily models like a greedy algorithm, which will favor the highest priority collection, and then build your collection plan against that. We've shown 4x improvements compared to those systems. Now you can definitely build a better what's called a heuristic system or an empirical function to do better against your specific satellites, against your specific targets. But again, those types of approaches are very brittle. Where if your mode of operation changes, or if your customer has a particular edge case requirement, those models quickly break down.
Yeah, and you were as well mentioning the fact that if you start to have like a model which is trained for various type of satellites, potentially it's you save a lot of time by deploying that exact same model of new generation of satellite with new sensors, which potentially you can save time as well on development time for
Yeah, that's exactly right.
for
So
that,
if
right?
you're deploying a new satellite with a new sensor, the exact sensor or which orbit you're flying or the size of your satellite doesn't matter all that much, because as long as we can model that satellite to capture the characteristics of that payload, and things like the footprint size and the agility of that spacecraft and the power constraints of that spacecraft, then we can use the same framework to train a new agent for that particular spacecraft without having to rewrite almost a single line of code. Right?
Yeah, so and I'm just curious as well about like one specific point. So you mentioned as well the different type of use cases and improvement for, I mean, commercial type of application. So we mentioned revenues, the fact that you can have like improve like the how quick you can handle like a customer order, for example. When we talk about like government organization, what's the type of improvements that this can bring to them? You mentioned image quality or transmission. That's the type of optimization.
So the work we've been doing on the optimization has been mostly on the commercial side. So it involves the satellite operator. Now we definitely have interest on the government side to potentially apply that for the management of government-owned satellites, to be able to improve the management and the responsiveness of those satellites. In the case of defense, speed is everything, and so if we can help increase the speed, that's always very interesting. Now, the work we've been doing on the government side has been a little different, and has been more focused on the downstream of how can we help them connect to multiple providers, and how can we streamline that process or orchestrate that process between these providers to do things like tip and queue and concurrent collections and things like that, where they want to have access to as much capacity as they can, but also a diversity of sensor types. So they want to be able to ingest spectral imagery or optical imagery or SAR data, and how do they get a full picture of what's going on the ground. And oftentimes that is a sequential effort where they'll first get a glimpse of what's going on with, say, a low resolution imagery, which would then trigger a higher resolution collection, either optical or SAR, or even now you can do thermal imaging to see inside buildings and what's going on there, or use hyperspectral to get a signature, a signature of a particular ship, and what the composition of that ship, right? And so you can do a lot more now with the new sensors that are coming online, and the government is trying to exploit that and trying to aggregate and make use of that data as effectively as they can. And so what we were doing there is working more on the demand side and helping them connect to those providers and be that orchestrator.
Do you see the market? How do you see the market evolving? Do you think that company like yours and software like yours you will be always like talking to individual satellite operators or constellation operators, or do you believe that at some point we'll arrive to a point where all that data will be just aggregated all together and you will see like on the market important players that fully manage like the data, and that in your case as a startup like on that field your objective is to try to get as many market shares as possible as quickly as possible to become one of all the two players that will share the entire market? Do you see that this is where we're going, or do you think like all the different satellite operators and constellation will still have individual data that I will not
There's
share
a
with other
wide
players?
variety of operators and what they offer to the market, and so um, one aspect of that is that there's some providers that only sell raw imagery without doing a lot of processing out of that imagery, and other companies that go deeper and actually do some analytics and sell the analytics output of their constellation. So there's a wide variety of satellites operators and what they're offering, and there isn't much of a standard right now as far as how that's being done. So that obviously is creating that diversity is interesting because it's creating new offerings, but it also creates some challenges in terms of friction and in terms of how that data is accessible and how you can predict capacity in the market and open up that capacity to the general market of other industries that are not government, right? And so the market's moving in that direction, but there's still definitely a lot of friction that needs to be removed for the market to really flourish.
No, sounds good. That makes sense. What's the next steps on your side? The next big milestone that you have planned? You mentioned that you were trying to. I mean, you're going to raise like another your Series A. Is that correct? In the coming months or year, can you
Yeah,
share like a bit more about that?
what I can share is that yes, we'll be looking to raise Series A this year, and definitely allow us to expand our offering, but significantly focus on sales and how we can expand the reach of our offering and um, the footprint of what we're offering. So um, yeah, so that is in our plans. I'd say stay tuned as far as when we'll be making those announcements.
Good, sounds good. Anything else you wanted
No,
to share with us, Guy?
I no, I think well, what I would share is that I think the space economy in general is really at an interesting point. There has been from an investment standpoint, there's definitely investors that are a little skittish about the space industry, and for good reasons. It has taken a while for the industry to grow and mature, and a little longer than a lot of companies were predicting or expecting. And that boils down to really a still, I would say, a lack of maturity in the market in terms of the infrastructure and how space is integrated in the overall market. And once those friction points are eliminated, that's really when I see the market really flourish and actually drastically exceed the expectations of what we can find in reports and market sizing analysis and things like that. So it's a bit of it's a bit of a ironic situation where it's taking longer than expected, but then once we hit that tipping point, then it's actually going to exceed wildly the expectations of the market.
Thank you so much, Guy, for sharing all of that. Really appreciate you that I had the pleasure to have you on board this podcast. Really appreciate that you shared your story. It's an amazing journey that you are in. I wish you like the best of luck, and yeah,
Excellent.
all my best.
Thank you, Jeremy. Appreciate it.
Thank you, Guy.